Here's an example on friction. So calculating coefficients of frictions, and there's actually 4 parts in this example. So let's take a look at how to tackle this. Okay, so you have a box, it's filled with IV bags, and it has been dragged across a horizontal floor. All right, so that's number 1. Now the box is filled with 25 IV bags with a mass of 250 grams each. So now we know how many IV bags we have and then how much each of them weighs or has a mass of. The mass of the box without any IV bags is 2.8 pounds. All right, and then they give us this ratio between newtons and pounds, which you maybe are familiar with. So let's take a look at and see what they're asking. Part A, if it takes 59 newtons to get the box to move, then what is the coefficient of static friction? Okay, so that's for part A. So let's take a look at that. Now I'm going to write down all of these givens so that I have them handy for myself. So first of all, let's figure out the total mass. This is the mass of the IVs, which is going to be, so there's 25 of them. Now be careful here because we need it in kilograms, so that's going to be 0.25 because it says it's 250 grams for each IV bag. So 1 kilogram's 1,000 grams, so you can do that transition there. So that's going to give us what the mass of the actual IVs is. So that's going to be 6.25 kilograms. You can just double check that for yourself. Okay, so if you do that multiplication. Number 2, so the other given is that we also have a weight. Now this is going to be the weight or the force of gravity. So I'll just put W. Now please remember that W is mass times gravity. Now here they are telling us that we have 2.8 pounds. So we do have to be careful with this because 2.8 pounds, right? We would want it in newtons, and then we can figure out what the mass is. So for this right here, I can do that conversion right there. So it's 0.2248 pounds. So the pounds will cancel off, and all you're going to get is now the actual newtons, which is going to be, so 2.8 divided by 0.2248. So that's going to be approximately, so 12.4, and then there's a bunch of 5s there. Now I'm going to just keep this for the moment. This is in newtons. And if you wanted to find out what the mass is right here, so then what you can do is you can take the mass, of course, take the weight, and then divide it by gravity. Now, since I already have the weight on my calculator, so I'll just divide by 9.8. And that's going to give me a mass of 1.27, 1, etc. So you can keep yourself several decimal places so that you can round later. So far, everything seems to have 2 significant figures for us, so I'll just round it to that later on. All right, so now we have the masses. So my total mass, this was the mass of the box, but my total mass would be the 6.25 plus what we just had, 1.27, etc. And so adding these two things up, I actually erased it. So 6.25 plus 1.2709, I guess was it 1? Let me just flip this back here so I can see it. 270, that's 71. I mean, I don't have to be that accurate, but let's keep it as accurate as we can. So 5-6 decimal places so that you're not worried about anything rounding errors. Now, why do I need the actual mass of this? Well, because I do need the total mass so I can find out what the total weight is. So you can go about it in different ways. Now, why would I need the total actual weight, which is, so in this case, because the box is being dragged. So if you have, your box and then the IVs are inside and it's being dragged, so let's assume it's being dragged to the right here. So there's going to be, some force of, force of friction in here. Now, within here, so it says that it takes 59 newtons to get the box to move. So what that means is this is going to be the, so the actual force, okay, force of friction, so force of static friction, so the maximum, once it's moving, we're going to be able to figure out what the actual coefficient of friction is, and that's going to be coming from the fact that we can have force of gravity here, and then we're going to have our force of normal, and because it's horizontal, so these two are going to be equal. So the force of normal is equal to the force of the gravity, which is going to be your total mass multiplied by 9.8, and therefore you have your normal force. Your force of static friction, so this is the maximum static friction, is 59 newtons. All right, so once we have these, so if I take this out, so let me do that all in there, so 7.520971 multiplied by 9.8, so that gives me 73.70, okay, etc. And now if you want to know what the static friction is, so that's going to be the maximum static friction that allows this object to move divided by the force of normal. So you're going to take these two items, so this one and this one, and then you're going to figure out, okay, so you're going to just do the division. So within here, so this is going to be 59, divided by approximately, I'm going to just put this right there, and then that's going to give us what that static coefficient of friction is. So let's, plug that in there. So 59 divided by 73.70, and I guess 55. So let's just put that, which is, it looks like 0.8. I'll put it to two significant figures, so I'll put that extra 0. Now please remember, because of the fact that your force in the numerator, force in the denominator, so they're both in newtons, so they will cancel, so there's going to be no units. There's actually no units associated with this coefficient, right? So this is always the case, so we don't need any units here. Okay, so that's the first part A. So it seems like it was quite a bit of work, but that was just because of the fact that we had pounds, and we started to have to add things up together, so we had to do a little bit of work to calculate that. All right, so that's part A. Part B, if it takes only 35 newtons to keep the box moving at a constant speed, then what is the coefficient of kinetic friction? Okay, well, so for kinetic friction, so for this one, as you're going through, so it's going to be part B. Now, in part B, well, what's really nice is that we already know what the force of normal is, so we don't have to go through all of that gibberish again. So 73.0, let's say 55. Okay, so we can keep it to that. You can keep more decimal places. I didn't actually keep it here, so that's unfortunate. I should have maybe. So that's my force of normal. Now it tells me that the kinetic, okay, so to keep it moving, I think this was what, 35 newtons. So this is 35 newtons right there. And now if you want to be able to find out what your kinetic coefficient is, so that's going to be just your kinetic static force, your kinetic friction force divided by the normal force. So now if you take those two, so again, so this is going to be 35 all over 73.70, etc. So if I take all of that, so 35 divided by 73.70, and so I'm going to just keep this to 2 sig fig, so 0.47. And again, it's going to have no units because the newtons would cancel off on both. So there you have it. So that's part B. So we have those two. Now part C, if you apply the same 35 newtons to the box when it was static, then what would be the force of friction? Well, so from part A, it's telling us, so notice that here in part A, this is 59 newtons, right? Just to get the box moving. So if you were referring to the fact, so now, let's say, if you had an applied force, okay, which was, I guess they're saying 35 newtons, okay, in here, Okay, so I'm going to just redraw this. So you have that. You're applying 35 newtons. Now, you know that your static max force is 59 newtons. Well, as you can see there, the 35 newtons is less than that. So you're not even going to get the box to move, right? So it's going to remain static, and the coefficient of friction and the actual friction itself, so whatever two surfaces we are dealing with here, okay, so that is going to prevent this thing from moving. So it's going to stay stationary. So if you're going to be applying this and you cannot go over this threshold, then you're actually going to have, okay, your force of friction, it always matches. So this, it's going to be the same. Now it's just going to be in the opposite direction. So that's going to be your force of friction here. So your force of friction is going to be exactly 35 newtons. And in fact is, no matter what applied force you have, if it is stationary box, so it's static, anything below the 59, it basically just the force of friction magically just matches what you are applying, okay, to prevent it from moving. So the answer is 35 newtons, okay, and it's not going to move. Now I think they asked something else, would the box move? No. So as I explained, it wouldn't move. Now for part D, if the box with IVs has been placed on another surface, okay, great, and you notice that an applied force of 33 newtons has accelerated the box at 0.4 meters per second squared, then what would be the coefficient of kinetic friction? So here, we're not exactly moving at a constant speed, but let's assume, okay, that we are going to be able to try to find that coefficient of kinetic friction. Now this is going to be a lot more work, okay, than the previous ones. So let me just copy this. This is going to be for D, and I'm going to just start labeling everything in here. So this is D. Let me put in, okay, and paste our free body diagram. Now we already kind of know these, so that's actually good. That was 73.7. So 0.7 0.55 newtons. This one is the same, so that's ditto. Okay, it's just a symbol for the same. Now the applied the applied force, okay, that they have said here. So you notice that the applied force is 33 newtons. Okay, so that's force applied. So that's 33 newtons. We don't know what this kinetic force, okay, is. We know that we are starting to accelerate, and this is our acceleration right there. So we're going to be assuming that we're accelerating in the same direction as here. Okay, so obviously friction is going to be in the opposite direction. So now we are after, and this is, you know, what do we want? Okay, so what we want, okay, in here, we want to be able to find out this. Now, in order to find this out, we need to know what that kinetic friction, the magnitude of it was. That was in the opposite direction, and we also need to know what the normal is. Now, the normal we know, so we already knew that before, but this Fk we don't know. So how do we find it from all of this given pieces of information? So let's kind of go back and think back of Newton's second law. So F net, right? So this is your total force. So in this case, it's going to be whatever applied force you have minus, okay, your kinetic. So notice they're in the opposite direction, so hence the minus there. And I'm dropping the vector symbols here. And all of this, so F net is supposed to be equal to mass times acceleration. All right. Now maybe I should write down, so what is the mass? So the overall mass, I think I put it in somewhere in there. That's 7.52, okay, 0.97. Let me just put 7.52. 7.52, you know, if your teachers are a little bit more strict, or profs, you can put more decimal places in here in intermediate steps. I'm just going to leave it at that. So this is what the mass was, and we're going to be needing it over here. And this is my acceleration, and we're going to be needing it over here. And notice that this is the applied force, and we can put it over here. Okay, and we have all of that. Now, so within there, I no longer need this right here. Now you might say, why? Well, because when you multiply mass times acceleration, you get F net, right? So let me just substitute that back in there. So let's see what this would give us. So 7.52 multiplied by 0.4. So that gives me 3, well, 3.008. So that's 3 newtons. I'll just put that in there for just for the sake. And this is going to be 33 minus Fk. So now you can rearrange this. And of course, if I bring Fk over on the other side, well, 33 minus 3, because if you bring this over on the other side, so you're going to get 33 minus the 3. So this is approximately 30 newtons. So that's my Fk. Well, once we have that right here, so now you can take it and substitute it back into here. Okay, so then, you know, substituting it for that, so my coefficient of friction in here, so it's going to be 30, and this is going to be over, so it's going to be, I keep forgetting, 73.70, whatever, 55. Now this one, of course, you know, we had 008 there. It's not going to make that enormous big of a difference for us. So now that's 73.70. Yeah, notice, so in here, so if you're rounding, you know, to 2 sig figs, all of them seem to be to that. So we're going to get our coefficient, right? So this is it. Now, so if you're looking at this, now if I go back, I don't even know what this was. Oh, notice, so this was, it's actually less, right? So then this one that we had over here. And that's how you would find it. So this example is actually a really good one for you know, static and kinetic friction, understanding how to find them, how to calculate them from some given pieces of information. All right, so thanks for watching. We'll see you in a future video. Happy studying.